Hi everyone. In this screencast, I'm going to be talking about ionization energy. So what is ionization energy? Well, ionization energy is the amount of energy needed to remove the outermost electron from a neutral atom. Sometimes I'll say it's the amount of energy required to eject an electron from a neutral atom, but that's saying the same thing as remove. Notice it has the root word ion in it. Ion refers to a charged particle. So when we talk about ionization energy, it's because we are forming a charged particle. When we remove an electron from an atom, that atom will now be positively charged because loss of electron means it now has one more proton than electrons. We have a trend for ionization energy on the periodic table. As we move from left to right on the periodic table, the ionization energy increases. That's what the height of these columns represent. So notice, for example, neon has the highest ionization energy of any element in its period. As we move down a group on the periodic table, the ionization energy decreases. So notice that as we move down this group, the ionization energy of the group 1 elements is going down. How can we explain these trends in ionization energy? Well, we should be able to explain them based on the shielding and effective nuclear charge as they change across the periodic table. Remember that shielding doesn't change as we move from left to right across the period on the periodic table, whereas effective nuclear charge increases as we move from left to right on the periodic table. Right? So shielding stays the same as we move from left to right, but effective nuclear charge increases. Well, using Coulomb's law, we should recall that our distance variable is related to the number of energy levels that is the shielding that an atom has. And the more shielding an atom has, the lower the force of attraction will be, because there's an inverse relationship between force of attraction and distance. But across a period, the number of energy levels isn't changing. What is changing is the effective nuclear charge, which, remember, is related to our Q1 variable. So as the effective nuclear charge increases, the force of attraction goes up as well, because they have a direct relationship. So when Q1 goes up as you move from left to right across the periodic table, so does the force of attraction. And this means that electrons are held more tightly for elements that are on the right side of the periodic table than for elements that are on the left side of the periodic table, and therefore it takes more energy to remove them. That's what it says down here. When force of attraction increases, it is harder to remove an electron. What about as you move down a group? Well, in this case, the effective nuclear charge is not changing. So in this case, the effective nuclear charge is staying the same. The effective nuclear charge, that is our Q1 and Q2 variable, is staying the same. But our distance, that is our shielding, is increasing. So as the amount of shielding increases as you move down the periodic table, the outer electrons are feeling a lower force of attraction, because we have an inverse relationship between the amount of shielding and the force of attraction. And when they feel a lower force of attraction, that means that electrons are easier to remove, and therefore ionization energies get lower.